this team of engineers is testing a model plane unlike any other. One that sees like a bee.
If you look at the things that a bee does with a brain that weighs less than a milligram, about the size of a sesame seed, you find these creatures can go fly several tens of kilometers, find their way back home and do a perfect landing. It doesn't use any radar, it doesn't use any LiDAR, no sonar, nothing, just vision, right?
The plane is equipped with 2 cameras that feed data to an onboard computer, like the eyes of a bee attached to a small brain.
So it has panoramic all-round vision, which means you can measure the motion of the world all around you and use that to guide your flight.
Good flying weather?
Yeah, it is quite nice. It's not windy.
The dream is to engineer a lightweight machine that can fly itself using a tiny amount of energy. And flying insects, like bees, are living proof that it's possible. At the Queensland Brain Institute, bees are giving up their freedom for science. This flight simulator for bees reveals how their vision enables them to navigate the real world.
By putting the bee in a tethered situation and having it fly in one place, we have a lot more control over what stimulus we can show to it. And we can also measure a lot more about how it's behaving.
So with feedback from the bee flying, it can actually control the images that are up on the monitors here?
Yeah, that's correct. We can measure the bee's thrust, and we can use that information to allow the bee to control the speed of the visuals that it experiences, and then look at how it's able to do this.
The secret is known as optic flow.
The image of the world moves in your eyes in a certain pattern. And by analyzing how that image moves, you can work out how far away different objects are, not only that, but also how you are moving within that world.
But what about when bees can come and go as they please and exercise their own free will? Well, that's what this is for, the all-weather bee flight facility. Inside, Nico studies how bees adjust to wind speed and direction to make smooth landings.
We just blow wind at them from different directions, and one thing which was obvious from the beginning is that as soon as there is wind and they get exposed to that, they turn their whole body into the wind.
He varies the patterns on the landing platform to provide different visual cues.
What we don't check with the bees is if there's perhaps some other pattern, another method they use to perform a secure landing.
Armed with data from these experiments, Srini's team of biologists and engineers develop visual guidance algorithms for their aircraft.
The computer is trying to perform what we call an Immelman turn. It does a half loop and then rolls back to level. So it's a fast way of changing direction. Well, the computer stitches together these 2 images.
Right.
It looks at the different colours in the sky and the ground, and we can see that where it thinks the horizon is, and it shows us the amount of motion on the ground and how fast it's moving. This is unlike our human vision, but it's very much like what a bee sees. What we're computing from that is which way up we are, very reliably. So it's much more reliable than typical sensors you have on aircraft.
Particularly in windy conditions, the computer can fly a lot better than I can, just purely because it can correct about 25 times a second, and I'm nowhere near that fast. Handing over.
Amazingly, this aircraft is now flying itself, the bee-inspired algorithms guiding it through a series of pre-programmed manoeuvres.
It still makes me nervous. At the moment it's using optic flow to hold 30 metres, and now it's doing a loop using the horizon information.
Did it pretty well, you happy with that?
Yeah, very happy.
Poetry in motion, mate. Like the bees, this plane doesn't use a GPS, radar or sonar to fly and land itself. It simply analyses the motion of the world past its eyes. And like an insect, it means this technology can explore uncharted territories, even another planet.
So you could put lots of sensors on these aircraft and do whatever you need to do with them once they can fly by themselves. Weather monitoring, for example, great for spraying crops. Surveillance in general, mapping out terrain in a particular area, reconnaissance. All of these things are very useful.